Every time you turn the key and set off on a drive, your car's engine is thrust into a relentless battle against one of its greatest enemies: heat. Beneath the hood, thousands of tiny explosions occur every minute, generating the power that moves your vehicle forward. But with that power comes an incredible amount of heat, enough to warp metal, melt plastic, and bring your journey to a screeching halt if left unchecked. Without a way to control this intense heat, vital engine components would be destroyed in a matter of minutes. Overheating can cause pistons to seize, gaskets to fail, and entire engines to be rendered useless. The consequences of unchecked heat are catastrophic both for your car and your wallet. So, what stands between your engine and disaster? The unsung hero of your vehicle, the cooling system. At the heart of this system is the radiator, a deceptively simple device that plays a crucial role in keeping your engine alive. Think of the radiator as the engine's personal air conditioner, tirelessly working behind the scenes to prevent a meltdown. It's constantly on duty, ensuring that the temperature under the hood stays within safe limits no matter how hard you push your car. The secret to the radiator's effectiveness lies in a simple yet powerful principle: heat transfer. By moving heat away from the engine and releasing it into the air, the radiator keeps everything running smoothly. Here's how it works. Hot coolant, having absorbed heat from the engine, is pumped into the radiator. As it flows through a maze of thin tubes and fins, the heat is transferred from the coolant to the metal, and then from the metal to the air rushing past as you drive. This process is a marvel of engineering, relying on the principles of fluid dynamics, thermodynamics, and clever design. Every curve, every fin, and every channel inside the radiator is carefully crafted to maximize cooling efficiency and protect your engine from harm. In this chapter, we'll take you on a journey through the radiator's intricate passages, following the path of hot coolant as it transforms from a dangerous engine-threatening liquid to a safely cooled fluid ready to start the cycle again. You'll see how each component works together to keep your engine at the perfect temperature, mile after mile. By the end, you'll understand why the radiator is not just another part under the hood, but a vital guardian of your engine's health and your driving experience. Let's dive in and discover the science and ingenuity behind this essential automotive hero. So, where is the radiator? If you've ever popped the hood of your car and wondered what all those parts are, you're not alone. The radiator is one of the most important components under the hood, but it's not always obvious to spot if you don't know what you're looking for. Let's break down exactly where you'll find it and why it's placed there. For most cars, the radiator is located right behind the front grille, at the very front of the engine bay. If you look through the grille, you'll often see the radiator's metal fins peeking through. This position isn't random. It's carefully chosen by engineers to make the most of the car's movement. This prime spot maximizes exposure to oncoming air as you drive. As your car moves forward, air is funneled directly through the grille and across the radiator's surface. This constant flow of cool air is crucial for dissipating the heat absorbed from the engine coolant. Without this airflow, the radiator wouldn't be able to do its job, and your engine could quickly overheat. You'll spot the radiator as a large, thin, grid-like panel, usually made of aluminum or copper with a series of small tubes and fins. Two big hoses are attached to it. One brings in hot coolant from the engine, and the other sends the cooled fluid back. These hoses are easy to identify and are usually the thickest ones in the engine bay, making the radiator stand out from other components. Because the radiator sits right at the front, it's also more exposed to hazards like rocks, bugs, and other road debris. That's why some cars have protective mesh or shields in front of the radiator to help prevent damage. If the radiator gets punctured or clogged, it can't cool the engine properly, so understanding its location and vulnerability is key to keeping your car running smoothly. The radiator often shares its space with other heat exchangers like the AC condenser, which helps cool the air for your air conditioning system, and, in turbocharged cars, an intercooler, which cools the air going into the engine. These components are usually stacked in front of or behind the radiator, all working together to manage heat under the hood. But out of all these parts, only the radiator is directly responsible for keeping your engine at a safe operating temperature. If it fails, the engine can overheat in minutes, leading to serious damage. That's why it's so important to know where your radiator is and to check it regularly for leaks or blockages. The grille isn't just a design feature, it's a functional air intake, channeling as much air as possible straight to the radiator. Some cars even have active grille shutters that open and close to control airflow, improving both cooling and aerodynamics. Every car's front end is designed around this vital cooling process. Whether you drive a compact sedan, a rugged SUV, or a high-performance sports car, the radiator's location is always a top priority in the design. So next time you open your hood, take a moment to find the radiator and appreciate its crucial role in keeping your engine cool and your car running reliably. The cooling process starts inside the engine block, where combustion creates extreme heat. About a third of this energy becomes waste heat, absorbed by the engine's metal. Coolant, a mix of water, glycol, and additives, circulates through internal channels, absorbing this heat. The water pump keeps coolant moving, while a thermostat controls when hot fluid flows to the radiator. Once hot enough, coolant exits the engine, enters the radiator, and begins to cool. The cycle is continuous. Hot coolant in, cooled fluid out, always protecting the engine. The radiator is where the heat, collected by the coolant, is finally released. This closed loop is the engine's lifeline. Hot coolant enters the radiator's top and is channeled into a network of thin, flat tubes, the core. The core's design splits the coolant into many streams, maximizing contact with the tube walls. Aluminum tubes conduct heat quickly from the fluid to the tube's exterior. As coolant flows downward, it sheds heat, cooling by the time it reaches the bottom tank. The cooled fluid exits, ready to repeat the cycle. The radiator core is a highly efficient heat exchanger, not just a simple tank. Its structure is engineered for maximum heat removal in minimal space. This is where the real magic of cooling happens. The radiator's secret weapon? Its fins, thousands of thin, crinkled metal pieces between the tubes. Fins massively increase surface area, letting more heat escape to the air. Bonded to the tubes, they draw heat out and spread it across a vast area. More surface area means faster cooling, just like pouring hot coffee onto a plate. The wavy shape of the fins isn't for looks, it creates turbulence, mixing air for better heat transfer. Turbulent air ensures more molecules touch the hot metal, maximizing cooling. Every fin acts like a mini radiator, working together to shed heat quickly. This design is why radiators are so effective, even in compact spaces. It's a simple, brilliant solution to a complex problem. Airflow is the final step in removing heat from your engine. As you drive, air rushes through the grille and radiator, carrying heat away, a process called convection. The faster you go, the more air moves through, making cooling more efficient. The bigger the temperature difference between radiator and air, the faster heat transfers. That's why engines run cooler on cold days and work harder in summer. Blocked airflow, by bugs, leaves, or debris, can cause overheating fast. Keeping the radiator's face clean is simple but essential maintenance. Airflow is the unsung partner in your engine's fight against heat. What about when you're stuck in traffic or idling? No airflow means no cooling, unless the radiator fan steps in. The fan, mounted behind the radiator, pulls air through the core when the car isn't moving. Older cars use mechanical fans. Modern cars rely on electric fans controlled by the engine's computer. When coolant gets too hot, the fan kicks on, drawing air through the radiator until temperatures drop. This on-demand system saves energy and keeps your engine safe, even at a standstill. You might hear the fan whirring after a drive. That's your cooling system at work. The fan ensures your engine stays protected, no matter the traffic. It's the backup plan that keeps you moving. The radiator system is a masterpiece of smart engineering, quietly working behind the scenes to keep your engine running at its best. While it might look like just another component under the hood, every part of the radiator system is carefully designed to manage the intense heat produced by your engine, ensuring everything stays within safe limits. Take the radiator cap, for example. It's not just a simple lid, it's actually a precision pressure valve. By maintaining a specific pressure inside the system, the cap raises the boiling point of the coolant, allowing it to absorb and carry away more heat than water alone ever could. This means your engine can operate at higher temperatures without the risk of overheating, even on the hottest days or during demanding drives. As the coolant heats up and expands, the excess is safely directed into the overflow tank. When the engine cools down, the system draws the coolant back in, keeping the radiator full and preventing air pockets that could cause damage. This clever cycle ensures the system is always topped up, maintaining optimal performance and protecting your engine from thermal stress. The coolant itself is a chemical marvel. It's not just colored water. Glycol is added to prevent freezing in winter and boiling in summer, making it effective in extreme temperatures. Special additives are blended in to stop corrosion from eating away at metal parts and to lubricate the water pump, extending its life. This blend keeps the system running smoothly year after year. Modern radiators are built from lightweight aluminum, a material chosen for its excellent heat transfer properties and its ability to help improve fuel economy. Aluminum radiators are not only more efficient at cooling, but they also reduce the overall weight of the vehicle, contributing to better performance and lower emissions. In contrast, older radiators were made from copper and brass. While these metals conducted heat well, they were much heavier and less efficient than today's aluminum designs. The shift to aluminum represents a leap forward in both technology and practicality, making modern cooling systems more effective and easier to maintain. Every detail matters, from the design of the radiator cap to the composition of the coolant, the shape of the hoses, and the choice of materials. Each component is engineered for maximum reliability and performance, working together to protect your engine from the inside out. Thanks to these innovations, today's engines can run hotter, cleaner, and longer than ever before. The radiator system helps maintain the perfect temperature, allowing for better fuel efficiency, lower emissions, and a longer engine lifespan. It's a testament to the power of engineering. An intricate system you can rely on, mile after mile, journey after journey, no matter where the road takes you. The radiator is the heart of your car's thermal management, quietly protecting your engine from heat. Every drive, coolant absorbs combustion heat and releases it through the radiator's tubes and fins. Components like the cap, fan, and fins all work together to keep temperatures just right. A well-maintained cooling system means better performance, efficiency, and engine life. Knowing how it works helps you spot issues before they become disasters. That temperature gauge on your dash, it's your direct line to this hidden battle. If you enjoyed this deep dive, subscribe to Daily Magazine for more engineering stories. Thanks for watching.